Alright, so in this video we're going to be looking at how to tackle Pythagoras within 3D shapes. So I've got two little examples. I've got a cuboid and then I've got a pyramid to look at, and honestly the best thing to do is just jump straight in. So we are being asked to calculate the length of A to G. So here's our A. We want to find out the point here all the way to the point up there, what that length is. Now, from the get-go, it can seem a bit overwhelming to figure that part out, but actually it's a relatively straightforward process once you can kind of sort of visualize the shape. So the key thing with Pythagoras questions is that we always want to try our best to identify a right-angled triangle somewhere within the question. Now, our goal, we have to have that green line at the end of the day, so we're definitely going to be using that as part of our right-angled triangle. And I'm going to see just what happens if I draw this line down here, because I actually know this first orange line here. I know that's 8 centimeters, so that's kind of a good thing that I already know what a bit of it is. And I've got these two lines and I've got to think, right, how can I create these two lines into creating a right angle triangle? And the only way to do that, because now I just need to draw the third side, is to connect these 2 points up. So there we've got a right-angled triangle, and our right angle happens down at this point here, where we go sort of into our diagonal, the part there. So I'm just going to quickly sketch that out. So this is sort of our end goal triangle, where I've got the A and the G, and that's what we want to find out. That's our X. And then our C to G, we know, which is this 8 centimeters. But right now I've got this unknown down here, and I don't actually know what that is yet. And I need to find that out in order to find out what A to G is. So then what I'm going to do is, looking at that blue triangle, I'm actually going to try and identify another right angle. And in fact, if I was to create a triangle along the base of my shape, where in this corner here where D is, that's going to be where my right angle's at, I've got this new triangle forming. So let's just quickly sketch it out down here. So this is just using that blue part. So I've got the A to the C, and that's the thing which I need to find out. And then A to D I know, which is this 10 centimeters, and C to D I know, which is this 7 centimeters. Great. I know two of the sides. I need to find out that third side, so I can use my Pythagoras formula to find out that A to C length in order. So find out this A to C length in order to know what this part is, to find out what my end goal is going to be. So I've got to use my Pythagoras formula now. It's opposite my right angle, so that means it's going to be the C squared equals 10 squared plus 7 squared. So that's going to be 100 plus 49. So C squared is going to equal 149. And so that means C is going to be the square root of 149, which is just going to be this. I went a bit weird. 12.205, 65 even, 655 and so forth. I don't want to round too early. Rounding too early can make mistakes later on. So I now know what that length there is. So I'm going to get rid of that question mark. I know it's going to be that 12.20655 and so forth. So now I want to find out what my AG is, and I am actually going to write that now as AG squared. So AG squared is going to be that 12.20655 squared plus the 8 squared. Now the important thing to kind of keep in mind, this part here, we found that from square rooting 149. So that means it is just going to be 149. So I don't even need to use a calculator for that. I just know that from our previous part of the question from before. And then the 8 squared, that's going to be 64. So then that's going to give me 213. So that means AG, when I square root 213, that comes out as 14.59451 and so forth. Rounding that to, let's go with 2 decimal places, that's going to be 14.59 centimetres. And there we go, that's my diagonal length. So let's go through the process again. I want to find this diagonal across from A to G, and I try and spot some sort of right angle triangle I can make. So I've got a line there, and that means my only other length is this bit down on the bottom. So that's where I got that first triangle from. Now the issue was I didn't know what that length from A to C is, so I looked to find another right angle triangle. So I drew out another one down here, and that created this secondary one. And then we worked through our unknowns to get to our final answer. So let's take a look at what to do for a pyramid. So being told below is a diagram of a square-based pyramid with a height of 12 centimetres. Calculate the length of A to E. So we're going to do kind of a similar thing again. So A to E, this is what I want to find out at the end of the day. That's my end goal. So then I'm going to try and identify where I can maybe draw out a right angle triangle using at least a side I know to try and help me figure out A to E. Well, I've got this length down here. I've got the height here, which is that 12. And so the only other way to draw out a triangle is to connect that point A to that bottom of our pyramid. So I'm going to draw that out. So we've got that A to E, this is our end goal. This is what I want to find out at the end of the day. I'm going to actually label that little bit at the bottom M for myself. And then I know what E to the M is, so that's going to be 12. But right now I don't know what AM is. So I need to try and figure that out first. So now I look to see, right, where can I create another right angle triangle? So the next one I can do is if I was to draw a line out just halfway along the bottom of my triangle, or my pyramid even, and then connect that out, there I can create quite happily that right angle triangle. Now the important thing to keep in mind, we've only gone halfway along, so that means that's got to be 3 centimetres. And it's a square-based pyramid, so that whole length is going to be 6 centimetres, so that means this is also going to be 3 centimetres. So I'm going to just draw that out, same as before. So that is going to be my A to the M length, and I've got that other sort of middle bit in between my A and my B. I'm just going to leave that one blank. And I've got this 3 centimetres, 3 centimetres, and what I want to find out first is that A to M length. So using my formula, and it's going to be the C squared equals A squared plus B squared. So I'm going to have C squared equals 3 squared plus 3 squared. So C squared equals that 9 squared, oh, not 9 squared, 9 plus 9. So C squared equals 18. So again, if I wanted to then find out what C was, square root of 18 comes out as 4.24264 and so forth. So then going to my end goal triangle, I want to find out what A to E squared is. So that's going to be that 12 squared plus the 4.264 squared. 12 squared is 144. And remember, we got this value here by square rooting 18. So that means when I square it, it is just going to be 18. And then add that up, that gets me 162. And so then AE would be the square root of 162. And that means that will come out to 12.8062 and so forth. Rounding that to 2 decimal places, that's going to be 12.81 centimetres. They can be a little bit funny, these 3D Pythagoras shapes, but as long as you work through the steps, drawing out the triangles, I highly recommend using highlighters for it. And then it can be just 2 simple, straightforward Pythagoras questions for you to work through. Let me know if you have any questions or any issues, and good luck with the work.